Kia ora Year 12. I just realised that I haven't videoed most of last year's Level 3 calc papers, so I'm going to get that done over the next few days. I'm going to start with this excellence question from the integration paper. It's a differential equation problem. And the thing I'd say at the start about this is if you've done lots of practice at trig derivatives, this question is really straightforward. But if you don't spot a pattern in here, there's a bit of a wild goose chase that I think some students probably went down. So we're given a DE, and this is it here. And we're told that x is between 0 and pi on 2. We're given a value, which is that when x is pi on 4, y is equal to 2. And our job is to find out what y is when x is equal to pi on 3. So you should straight away be thinking, yep, I'm going to need my special triangles in here. So let's start off, and we're going to separate the variables. So let's write the equation out first, how it is, and just have a look. So we need to get the stuff with x on one side, and the terms with y on the other side. So that gives us here y dy is equal to sec squared x over tan x dx. And I think it's really easy at this point to jump straight away to try and replace the sec squared and the tan x by cos 1 over cos squared and by cos x over sine x. And that's not good. I'm actually going to show you what happens if you try that way at the end of the video. So here we're going to integrate both sides. The left-hand side is straightforward, so we're going to make that a half of y squared. And then here, the pattern that we want to spot is that when I differentiate tan x, I get sec squared x. So this is not a difficult integral. This is just the natural log of tan x with nothing else plus c, right? So now, instead of trying to get an expression for y, let's just substitute in here, right? Remember that we can do that at any stage in the working. So when y is 2, x is pi on 4. So 1/2 of 4 is equal to the log of, so tan of pi on 4 is simply 1. So that's very easy. Now I've just had the dog appear in the study, and my shoes are here. So I'm about to pause this and make sure she doesn't do anything silly. So c is equal to 2. I'll keep going for a little bit. Right, so we're back to this. We've got a half y squared is equal to the natural log of tan x plus 2. Right, she has taken one of my shoes, so I will be back in a minute. Guys, I'm back. So now we've got this nice equation, and all we've got left to do is to substitute in. We need to find the value of y when x is pi on 3. So we're going to use another special triangle for that. Okay, so sorry about the coughing fit. Now we've got to find y. So we've got half of y squared is equal to the natural log of tan of pi on 3 plus 2. And here's my little triangle with pi on 3 in it. So it's this angle here. So we've got a half y squared is equal to the log of root 3. We can remove the absolute value signs now because we've got a positive number, plus 2. So just before I figure out what y is, let's just times this through because it cleans up quite nicely. So we've got the log of 3 to the power of a half here, plus 4 because I'm multiplying by 2. And so if I do my year 11 or year 12 log rules backwards, I get y squared is equal to the natural log of 3 to the power of a half squared. So it's just the natural log of 3 plus 4. So y can be either the positive or negative square root of the natural log of 3 plus 4. So when you've got a question like this, and it's an excellence question, and you're trying to like really do it well, you need to have a good look at whether y really can be both of those two values. So we go all the way back to the start here, and we see that we had a restriction on x, right? But that doesn't tell us anything about y. So there's no limitation here for the y value. So to get full marks in this question, you do need to put the plus or minus because y could be negative root natural log of 3 plus 4. And because we're not asked for an exact value, we will put that as plus or minus into 3 decimal places. It's 2.258. So there you go. Make sure you go through that one carefully. There are quite a few good revision steps in that question. I think it was a nice level 3 question. Thanks for watching.